We're now on examples 4 and 5 of section 9.2, estimating population mean. Examples 4 and 5 are theoretical type questions. They're asking us if we remember some things we learned about when we were estimating population proportion. We did some sort of explorations to find out what happens if everything stays the same, but we change our confidence level. And example 5 goes back to where we kept everything the same except the sample size and what changed with our confidence interval estimate when we changed our sample size. So let's first look at example 4. We have a sample of packages that are randomly selected from packages received by a parcel service. The packages are weighed and the sample mean weight and standard deviation are calculated. And then two confidence interval estimates are constructed. A 95% confidence interval estimate and a 99% confidence interval estimate. Which of the two confidence interval estimates will be wider? And we need to explain our answer. So do you remember what we said about the larger the confidence, the higher your confidence, what happens to the confidence interval? So if you want to be more confident, if you think about that dartboard example I gave you, if you want to be more confident that you're going to throw the dart and hit the bullseye, does your bullseye need to be wider or more narrow? You need a wider confidence interval in order to be more confident you're going to hit it. You need a bigger bullseye, right? If you can't move, you have to stay in the same place. You want a bigger bullseye if you want to increase your confidence that you can hit it. So the 99% says which would be wider? The 99% confidence interval estimate. Remember, if we wrote down the lower bound and the upper bound for both of these, we know that this one would be wider. And why are we saying that? Because to increase our confidence that the true population mean is in the interval, we need a wider interval. And wider means more variability. In other words, of course you got, and remember, that's how spread out the data is. And of course you're going to have more numbers. If it gets wider, you've got a lot more variation in the possible numbers it could be, right? So to be more confident, you need a wider confidence interval. Well, what about sample size? Let's see what that does. Two samples now. A sample of 100, a sample of 200 of packages are randomly selected and they are weighed, and the sample mean weight and standard deviation are determined to be the same for both samples, so those stay the same, and the same confidence level. We're going to do 95%. The only thing that's different are the sample sizes. So which two of the two confidence interval estimates will be wider? The one with 100 for the sample size or the one with 200 for the sample size? So what we saw before was, as you increase the sample size, you decrease the width of your interval. So in this case, the confidence interval for sample N1 which was 100, would be wider. Because a smaller sample size will result and more variability. There's that word again. And that just means if there's more variability, that means the value can vary more. Well, it can vary more if you have more values, and you have more values if it's a wider confidence interval, right? The more narrow it gets, the fewer numbers it could be. The wider it gets, the more numbers it could be. And if you increase the possible number of values, you're increasing how much variability is in the data.